Hey, brilliant minds, welcome back to Logic Unlocked. Today's problem is one of the twistiest summary problems out there. Lead code 152 maximum product summary. As you can see on the screen, this one is all about smart handling of negatives, zeros, and signs. Problem statement says that you are given an integer array of nums. You you need to find the contiguous subarray with the array containing at least one number that has the largest product. Sounds like Kadance, right? Wait till you meet the negatives. Here now, this is where things get spicy. Unlike Kadan's max sum, we are working with products. And here's the twist: negative into negative is equals to positive. Zero sets research the product. A big positive can turn into a big negative if multiplied wrongly. I think you know this. So we need to track both the current sum maximum product, the current minimum max product, which can become the max if multiplied to a negative. So this is the magic at every step. Track both maximum and minimum and update the answer. So this is really good question. See this. This is a dry run. I have taken here example as 2 comma 3 comma minus 2 comma 4. This is my array. So now maximum product, minimum product and the result whole will be setting to the index I is equals to 0. At I is equals to 0, the digit is 2. So it all sets to 2. And when we go with I is equals to 1 iteration, we'll be seeing like nums of I is equals to 3 because I is 1. 1 at 1, it is 3. The value is 3. So here it is 3. So it is a positive. So there is no swap. As I have mentioned in the code, if there is a negative, only if there is a negative, we need to swap. There is no negative. 3 is a positive, so no need to swap. Let's continue. So next, maximum of product will be like 3 comma 2 into 3. Maximum of 3 comma 6 will become 6. Next, minimum product will be like 3 minimum of 3 comma 2 into 3. That is same thing. 3 comma 6 minimum will be 3. So 3 is considered to be minimum product. Result will be maximum of result comma maximum product. As you have seen here in the logic, let's go back. Yep. So result is like maximum of result and the maximum product. So we'll be if when we check that, we'll be getting 6 because maximum of product is 6. Okay. Next, I is equals to 2. If we consider I is equals to 2, 0, 1, 2. So index at 2, the value is minus 2. So minus 2 is negative. Then it will be swapping. So before swapping, the values of maximum product is 6 as you have seen here. Minimum product value is 3. So after swapping, maximum product becomes 3 and minimum product becomes 6. Got it? So we will perform the operations now. Maximum product is equals to maximum of what? Maximum of I. That is nums of I. Okay. Maximum of this and 3 into minus 2. That is maximum product into this. Okay. Nums of I. So after doing that, we'll be getting minus 2 comma minus 6. As you have seen here, same thing happens here. But here in this case, it is minus. So in minus values, we'll be taking minus 2 as a greater because negative values, small numbers will be having a larger value than the larger number with a negative symbol. So we'll be considering minus 2 to be the largest one. And this goes on. We'll be getting the 6 as a maximum here, same as we got before. The result as 6 here. After looping I is equals to 3, also we got this 6. And this is all because the subarray was 2 comma 3. So answer is subarray is 2 comma 3. Okay, this is about it. This is a code and this is a thing. So if we check the any other thing, it wouldn't be that same thing. Okay. So at the end, it is a result 6. How do we get the 6? By producting. 3 and 2, right? 3 into 2, that is 6. So it is this longest subarray. Maximum product subarray. No. Okay, that's it, guys. Have a great day. It's like interview site. Interviewers love this because it's not brute force. It shows you understand edge cases, when to research, and when a small value can turn into big. Like for example, like maximum product is at 0, and this minimum product also at first place. Result is also at first place. Like if I is equals to 1, then I less than the size of this I plus plus. If this element inside that is less than 0, then we need to swap with the maximum product and the minimum product. Now in the maximum product, we'll be finding the maximum of the number and producting with maximum into the element. We'll be seeing which is the greater. And here the same case with the minimum, and result will be stored. That is the maximum product we want. First, we will be filtering a maximum one and the minimum one. Then we'll be tracking it. So when a small value comes, like suppose if a negative value comes, negative and negative comes, the whole story changes, because when we multiply with something, even if it's a big number, because of symbol, its value reduces. So we it's most important to filter. That's the reason here we have put in the result maximum of result and maximum product. Here minimum is used because to reduce the errors, like to remove the negative values. Got it? It will be stored in this minimum product. I'll be showing you this by the dry run. First thing, the time complexity would be big O of n, and the space complexity is big O of 1. So